the recording. Yeah, so as we are understanding, DevOps is not the tool, DevOps is the process model. So which is helping that to have that enhanced communication, collaboration, and integration between the developers and as well as operation engineers. That is administrators, network administrators, system administrators, or middleware administrators, database administrators. So all the teams, the coordination is very, very important. Yeah. So this was the thing that we were understanding yesterday. So anyone having any queries, questions, please let me know. To go ahead that now to conclude it, how that can be handled integrations, continuous integrations, continuous deliveries or the deployment, what is the difference of it? Continuous testing, how do we handle that? Continuous monitoring. And how do we have that like development environment is equal to the production to reduce infra related issues? Now we go for the talking the challenge. The solutions on it. Are you ready? Or anyone having any queries, questions, please let me know quickly in the chat window. Or you can speak it, not an issue. Or if you're good, type that. Go ahead to continue to this next one. Good, go ahead, go ahead, go ahead. Does Agile model also have errors? Yes, definitely. That is the limitation as we are understanding that main challenge in the Agile is 2 points. Developers daily, like they need to work it on that implementation of the code, and as well as they need to interact with the client, and they need to get that all the changes on that day itself. Yeah, so having the scrum meetings and getting that like reviews and applying that those changes immediately, that is one thing. And not only that, one more point, if we just talk at that, as integration point of view, so it is not just only one developer. Now I'm going to talk about the challenges of it. So main continuous integration, continuous testing as a 2 teams role. So in the Agile, main 2 teams with the client. The daily interactions with that. Yes, other teams also, if it is required, like operation engineers, yes. So any changes on that infra level, platform level. But the challenge that is the testing teams and development teams. That is I'm going to talk it. And one more point here, Agile and DevOps both are using, yes. So Agile to coordinate it and communicate it among clients with the developers and testing team in the iteration process model. And DevOps is for that developers, testers, and operation engineers coordinations. Okay, so now let's go ahead understanding that. Yeah, so that is a wide screen only. So I'm going to just start about it. Yeah, so now let's first have it that word. What is the continuous integration? So total, always remember that DevOps in it, 5 principles. Integration, continuous delivery, deployment, continuous testing, continuous monitoring. There are the 5 principles always we need to remember it. But what is a continuous integration? What are the stages that is involved? So developers, once he is ready with the code, but where the code will be managed or code will be stored? Are we going to store the code in our local systems or developer systems? If you have the 10 developers, each developer is going to have in his local system the code which he is implementing, but end of the day, it has to be sorry. So it has to be uploaded to that repository. What is a repository meaning? It is kind of storage server. Suppose what all the photos or what all the videos which we have, finally end of the day to store it, we use it some Google Drive or Dropbox, right? Or OneDrive. So like that, where do we store that the source code is? Developers, what are the code which we are implementing that is in the source code repository. But as we're talking that 10 developers, but any developer update the code here, immediately start the pipeline. It has to verify it. Okay, some update is happened here because this is the main repository. The entire project code. This is not just like only one developer code. So any update is happened here, immediately it starts the pipeline. So we need to start the pipeline. But what is the pipeline contains? But how do we monitor about this one? So how do we like get the notification if some developer committed the code to repositories, that is source code repository? Be specific. We are going to talk it like almost 4 or 5 different repositories. Repository is a server where we can store files. But here, which type of the files we are going to store it? Source code of the application. Yeah, once the developer commits the code to the source code repository, immediately it starts the pipeline. So that's we can say that Jenkins is going to keep on monitoring about it, and it's trigger the pipeline, triggering. That means yes. Instead of doing that manual activity, we are going to use this automation tool. So it is like as a human being, which is keep on monitoring about our source code repository. Yes, any code is updated here, immediately it starts the pipeline. So immediately it is going to verify the code, whatever the developer committed, the code, is it having any errors or not? It is going to check in that. Errors verification. If you have that any errors, developer committed by mistake any errors, then immediately it stops here and it is going to send the mail to the developer. Boss, this is the error which has been identified. So please resolve it and fix it immediately. That is about compilation phase, we say that. That is verifying the errors. If no errors, whatever the code he has committed, no errors, good. Let's go ahead to the next stage. What is the next stage? As we are understanding that a developer, they need to make sure that quality of the code also, not just implementing the functionality. So whatever the code they are implementing, the code should have or should follow the standards. That's we say that code quality. And it should not have that in that code any security related issues like a password hard coding or keys hard coding. They should not do that kind of the implementation in the code. So immediately this code quality tool is going to catch that any security related violations, or if the developer is not following the standards, immediately it will be caught here. And after catching those the errors, immediately it will send the mail to the developer. And developer, yes, he has to fix it and he has to recommit the code. And again, it will be reviewed back. And now if it is okay, yes, it will be promoted to the next stage. That is approvals. If it's, everything is okay, the code quality and everything, it will be approved. Okay, once this stage has been completed. So here, if you just observe, there are like a code compilation or code quality verification. We say that static analysis also. The process model, we call it static analysis. Fine, good. So once this is done, what next? Now, as this developer, whatever the code he has committed, but we have remaining 9 developers code also, right? But it's not just only one developer code here, the entire project code. If you have the 10 developers, all the 10 developers code, it will be managed in the repository. So immediately, it has to run it unit test cases. So developers, each developer, whatever the code they are implementing, they need to verify it. So that's we say that running unit test cases. So if all the unit test cases are passed, that means his code is okay. And his code is not impacted, like other developers test case also will be verified. Not only these developer unit test cases, this is project level. So if the unit test case are passed, that report will be generated and everything is okay. It will be promoted to the next stage. What is the next stage? So source code, normally we don't execute it directly. We don't run it. Suppose if you just observe that whenever we are downloading any softwares on the Windows, we will get it either a GIF file or .exe file. But they don't give that entire source code. .zip or .exe, these are all like a packaged files, packed files. Or even in our mobile also, like we are installing the software is nothing but yes, backend it is going to download the APK files. So on the base of like application type, we have the packaging models. So we need to do that packaging application. If it's the Java based packaging, or if it's the mobile based application, that is yes, as per that like Android based package. Or if it's the .NET, yes, DLL based applications or GIF files. Yeah, these will be packaged. But packaged files, where do we manage it? Are we going to manage it in the local system? Because this is important, right? This file will be used as a release file. So where do we keep it, this file? Like these are all like supported files or deployment files. So this also will manage it in the separate repository. Separate repository. That's we say that artifactory repository. This is about source code repository. So this is like a developer's code. But developer's code we cannot run directly. Developer's code, we go for that, doing all these phases, and after that we package it. Packaged files will be used for the release point of view. So we manage it in the separate repository. Repository, we know that storage is server. But here, which files we are going to store it? Artifactory. Yeah, large number binary files stored in the artifact repository. There are like yes, we can say binary files, output files, artifactories. So once the packaging has been done, now this packaged file will be taken and it will be deployed to the servers. Deployment. So this one we can say post deployment also. This is pre-deployment. Before that, all these steps we had done pre-deployment, pre-packaging. Before doing the packaging, we were doing that all these steps. Now, once all these steps are okay, then we are doing that converting into binary file or executable file. And these executable files will be taken and deployed to the server. Suppose if it's a Java application, Java servers. If it's a Python-based application, Python servers. Or if it's a .NET, .NET-based servers. Or if it is the Android, Android-based. Or if it is ML, ML-based deployment. See, process is important for us. Which type of application we are working doesn't matter. We are going to work for that web applications or REST APIs or LLM-based applications, that is machine learning related. But about our process is the standard process. So deploy to the server that packaged files and then run that test cases which are planned. These are like we can say integration test cases. These are all like unit test cases before the packaging. These are all small units of the code verification. But units like the entire application, right? That entire application integration related test cases that will be evaluated here. If you have completed all these stages, that's why we say that integration is successful. So just think about it. Once one developer, one line of the code he changes, it should be done this entire process. Like that, daily, if we take that average 10 developers, each developer on an average 15 to 20 times he is going to commit the code. That means almost like the 150 times on an average, these pipelines are executing that. Or even if it is more developers, more work they are doing, more enhancements they are performing, then it will be increased or it will be decreased. But if you are going to do these activities like code quality, compilation, running unit test cases, packaging of applications, deploying that application and running the test cases, if you're going to do that manually, think of it that how much effort that is required. But that effort, we are going to reduce it by implementing these kind of the pipelines. So this is one part we are talking that is the integration part. But here it is there, yes, running unit test cases and integration test cases. Yes, test cases are also involved in that. Pre-deployment and post-deployment. Are you clear about that integration? Continuous integration? Type that CI in the chart window. So whenever we are talking about it, integration, then you should remember all these stages. But on the base of the programming language, like if it is the Python, we don't need that compile phase. But if the Java, .NET, we need this phase. Yes, phases are going to changing. But we have the standard approach. So while designing this kind of the pipelines, yes, we need to implement it. So we'll approach development teams because they are the masters on the source code side. And whether it is required to compile or not, whether it is required to run the test case or not, packaging, deployments, what are the servers it is required to use it. They are the masters, but we will help you to design all these stages and the steps, and we will keep on monitoring it. Whenever anyone commit the code here, yes, is it everything okay or not? That is, we are going to manage it. Yes, for each project, the pipelines are the different. On the base of the technology, on the base of like a test case, I mean, evaluation models, approval models, it is going to changing that. Yeah, this is about integration, but integration is not enough. Integration is, okay, so you have verified the code and everything is okay. And you have verified his code has been impacted to other developers or not. That is about integration. My code, it should not impact to about your code because we both are working on the same project and you are also committing the code and I am also committing the code. But my code should not give that impact to about your code, or your code should not give that impact to my functionality. So that is verification about integration. But integration is not enough. It has to be applied that either delivery or the deployment. But what is the delivery or the deployment? Are we talking about it only one environment or multiple environments? So development environment, then like functionality testing environments, or system testing or load testing environment, or UAT environment, and finally the production environment. Now you got it artifacts, right? So any developers commit the code, we are going to check the code, we are going to check out the code, and we are doing the code evaluation, running that unit test cases, and we are building that artifacts. Artifact is binary file or release file. And release file, what do we do that? We deploy to the testing environments. So deployment to the servers. And after deploying, we need to evaluate the test cases. That is running all the test cases which are planned in this environment. That could be functionality test cases or regression testing. So different types of test cases. But who will come into the picture? That is testing team. So we need to run it all the test cases and we need to verify it or accept it. Yes, after verification, if everything is okay, accept it. If it is accepted, so here we are talking that, let's assume that in this testing environment, 2 servers. Yes, 2 servers, we need to deploy this artifact and we should get ready of this. Then next, like a load testing environment, a performance testing environment, or we can say non-functionality test environment. Once this is approved here, which will be promoted that artifact. Okay, download this artifact and get ready of this environment. So once it is deployed here, and all the test cases which are planned, that is load testing. Load testing is, yes, suppose one user is asking, 1 lakh users are asking that, yes, how the servers are responding, how the storages are managing that, how the CPUs, memories. Yeah, so this one we can say the functionality test case. This is suppose like a TCS is doing this project management. So this side, TCS testing team is working here. But the TCS has delivered that project to the Google. Yes, Google team is coming in the picture and they are going to work it in the user acceptance testing. user side. This is about our vendor side. But before going to hand out to the vendor, we need to verify internally the functionality related, non-functionality related. If it is working, everything, and if we confirm from about our side, then we will hand over to the client. That is the vendor side. And vendor, he is going to have his own environment where this, once this is accepted here, it will be released to the UAT environment. And here all the user test cases, whatever we have, it will be verified here and evaluated and accepted. If it is accepted, then finally it is promoted to the production environment. See, artifact is only one, but that artifact which has been released for different environments on the basis of that evaluation and acceptance. Here testing team evaluations, and here load testing and user level testing, and finally the production. But here are you going to have only one server? So here maybe 2 servers, here maybe 5 servers, or here maybe 4 servers, here maybe 20 servers. But how do we release these artifacts? 2 plus, 4 plus, 5 plus 20. Almost 30 servers. How do you manage it? 30, 40, 50, or 100 or 1000. So this is another important challenge. How do we deliver that change? How fastly we deliver to that functional test environments? And once it is ready, then how do we deliver that change to that like a performance testing environment and getting ready and run the test cases and get that approval? And once it is ready, then how do we deliver that change to that UAT environments, UAT servers? And how do we run the test cases? And how do we get that approval? Once it is done, how do we release to the production? So here we are saying the delivery or the deployment. Continuous delivery or the deployment. This is not just one time. This is also regular activities. So with these agile process models and DevOps process models, if you just observe that, especially DevOps is continuous deployment of that different servers in the different environments and continuously running the test cases. If the test cases are evaluated and accepted, then move into this next environment. That is deployment. Once the deployment is ready, run the test cases. And once it is accepted, then move that application to the next environment. This is here continuous delivery or the deployment and with continuous testing. So if you together that, yeah, so DevOps process model finally continuous testing, continuous deployment, continuous delivery, and continuous monitoring. Yes, monitoring is also important. We need to suppose we have now almost like 50 servers, just example. All the 50 servers, how those are working? Or what is the status of that? About the storages, about the system performance. In the live environment, if the users are asking that any challenges for them, maintenance issues, backups. So all that's the things that we need to have it that is monitoring. So testing, deployment, delivery, monitoring, these are all some stages which we have this in the process model with the DevOps. Finally, altogether, if you combine that Agile and DevOps. So what is that Agile model? Yes, it is, we are talking about it. Identify the priority of the work, design it, develop it, build it, and run the test cases. That is a continuous integration model. But once integration is done, continuous testing, continuous delivery or the deployment, and continuous monitoring. So finally, if you combine that Agile and DevOps, So continuous integration as a continuous delivery or deployment. So identify the user story, design it, build it, and test it. So once it is verified that the integration level, then take it and apply to that test cases team. Testing environments and run all the test cases. Then if you have the slow testing environment, deploy it and run all the test cases which are belong to that environment. And then deploy this to that user level UAT environment or pre-prod environment and run all the test cases which are planned here. And if everything is okay, then take it and deploy to the production and run the test cases. And if all are okay, that's good. Or if something is wrong in any one of the stage, then get that. So review about it, that's stage, and do that like a modification here, and again do the process of it. So this is about that model. Combining about that Agile and DevOps. So finally, if you the club together, that is requirements teams, development teams, testing teams, and with IT operations teams. So continuous integration, continuous testing, continuous delivery or deployment, and continuous monitoring. These are all important principles which we should know that as a DevOps engineer. Are you got it? Have got it, these points? Type that DevOps principles in the chart window if you understand it. The 5 principles. Whether you are working for the web application, whether you are working for ML applications, or you are working for that REST API based application, doesn't matter. That as DevOps engineer, there are the 5 points which we need to remember it. But as per the application and application model, tools are going to changing that. Tools are going to change. What are those tools? Common tools. That's we will talk it. We'll come back. Type that everyone DP in the chart window, DevOps principles. Or if you are more clear, 5 DP. 5 DevOps principles. Yes, good. 5 DP, yes. CI/CD, CD, continuous delivery, deployment, continuous monitoring. Good, awesome, man. Thank you. But here, if you just observe that we are talking that delivery deployment, what is this difference? Okay, we understand integration models, we understand testing, we understand, yes, monitoring, make sure that the servers availability, scalability, high availability, yeah, there are some points. But what about these? Why do we have the difference? Different approaches here, deployment and delivery. Do you have a question for this or not? Or do you understand the deployment and delivery? So let's look into that. What is the delivery or the deployment? Yeah, CI/CD. CD, some of the process models we use it delivery. In some of the products and some of the process model, we say that deployment. But CI is the common. What is the CI? Once the developer's code is ready, build it, run the unit test cases and deploy that to the staging environment and run all the test cases. That is the functionality. Test cases, whatever it has been planned. So complete it this process. So if we have completed these stages in the process, we can say integration is done. And it is done with automation approach. There is no manual involved here. Yes, if any developer commits the code to the source code repository, do the code quality, then run that unit test cases, then deploy this to the servers, staging servers, or testing environments. or QA environment, different keywords on the basis of the client and project. But simple, deploy to the staging or testing environment and run the test cases which are planned. If it have completed these stages in the pipeline or through the pipeline, we can say integration is done. But integration is not enough. This is up to testing environment. But finally, we need to deliver that application to the end user, that is a production environment or live environment. That is important. So integration is not enough. We need to go for that either delivery or deployments, we need to use it. But what is the difference between the delivery and deployment? Yeah, so here, once integration is done, now we have like UAT environments, production environments, right? Yeah, main objective is production. But once evaluation is done, and if you are promoting these changes to the production environment with a manual approach, so manually verifying that and manually accepting the process, if the manual process is involved, then we say that delivery. See, some of the telecom based applications, everything we cannot do that automation. So we have some device dependencies, which is required to verify that. Or in some of the products, like before delivering to that end user, functionality team, they will verify it. So functionality team, they comes into the picture and they need to verify it and they need to approve it. And once they approve it, it will be promoted to the production. Or if they don't accept it, it will be stopped here itself. And it has to go back and review it and reprocess again. So if the process is designed with a manual promotion to the production, that's we say the continuous delivery. But if the process is designed without having any manual promotion to the production, that means everything has been automated. Switch here, bulb here. So remaining everything automatically it has been processed. That if you have defined for about your project that kind of the process model, we say that deployment. There is no manual intervention in the process. But all the applications that is not possible without having manual. Yes, some of the clients, they come up with that. Yes, we need to go for that manual. There is only 80% of the test cases are automated, but remaining 20%, yes, which we need to go for manual verification. And once it is manual verification, they do that acceptance to promote to the production. If this process is designed, then we say that delivery process model. Or if everything is automated, like as yesterday we were talking about it, Amazon. So he's doing that daily 1400 releases on average. But how they are doing that? If they have that manual, that is not possible. But as for their e-commerce based application, they have come up with that everything automated, entire process model about ordering system, invoice system, or what are like product management. What are the modules they have that everything that's any changes which are required, yes, they have automated. I've got the clarity on this now, that's delivery and deployment. Type that CLR in the chat window. Or you can say 2 CDs. That is one continuous delivery. Yes, this is one of the important point. You should understand the difference between the process model. So whether you are using the delivery or the deployment models. Yeah, that is on the basis of the client. We don't decide it. But yes, we should implement it. So during working with that and managing these process models, we should have the clarity about it as per the client requirement, whether we are doing the delivery models or deployment models. Don't worry about it. That's will come back. But understand that's the firstly the terminologies. It is just started, it is not ended. As I just mentioned also, telecom domain, it is not possible everything automated. Or functionality teams, because different project, different scenarios, different suppose like as I just mentioned that Amazon e-commerce based application, it is not involved any manual approach. It can be automated. E-commerce based application, it can be automated. As already mentioned about that, those examples. And here telecom domain, device-based dependencies. You cannot do everything automation. So that project yesterday has been applied that there is a manual requirement. So that is about CI and the CD. That is a continuous integration, delivery, deployments, and testing, yes, and finally monitoring. So, but how do you go ahead? So all these approach, manual approach, if you go for that, yes, like I mean important some stages if you observe that. Suppose if you're going to deploy that application, first you need to have the virtual machine, right? Server. Then we need to have the platform. Server, if I'm talking, this is nothing but that should contain the storage, memories, CPU, that is a processor unit, operating system. So all this together. Then if it is a Java-based application, yes, we install the Java, then we need to go for that, install the server, then configure the server, finally deploy the application. So if you're going to do this, all these manual activities, it takes time and effort. But yes, we can do that, all these things automation. But in this, I mean, if you're going to convert this manual to the automation approach, suppose here provisioning the server. That means configuring storages, configuring memories, configuring process units, the managing with operating system, with virtualization concepts, all the things that should be handled. Yes, how do you do that? Yes, that is infra provisioning. We say this is infra, as we are talking that infra layer, infra provisioning. But what is the best tool that is available? That is Terraform. And then coming to that, how do you install the Java? How do you install the Tomcat and how to configure the Tomcat? They're all Java-based application platform. If you're going to run the Java application, yes, you need to have all these softwares. That is, we say the platform provisioning. Here we can use the Ansible, shell scripting, or we have the configuration management tools. And finally, we need to deploy that applications. That is a build tools. How do you build it? And how do we distribute it? Yes, we can take the build tools and we can use it with these configuration management tools, and we can use it these automation scripts, that is a shell scripting or Python scripting. So manual approach converting into that automation approach. Yes, using these tools, Terraform, Ansible, shell scripting, we can do that automation. Even launching that complete the infra from the networks to the operating system level, all the things we can automate it. We can write as a code. That is Terraform. And once infra is ready, then we need to go for the platform management. Yes, we have that configuration management tools with the automation script. But not only that, I mean, here there's points like as the latest application model, if you observe that, microservice-based applications are available in the market. Microservice-based applications like a Docker, Kubernetes. This is one of the very, very important. Yes, we are going to give that a high priority to these as well as. But before going to work with that microservice, the monolithic, you should know it. Monolithic. But how do you move that monolithic application to microservice-based applications? But whether the monolithic application or microservice-based application, yes, they're all the stages that is required. Yeah, Docker, Kubernetes. That means, I mean, now if you just observe that tools which you are talking that, Terraform, infra management, Ansible and shell scripting, that is a platforms management. And Docker and Kubernetes, we should know that if that application is microservice based. Yes, in the ML based application, these are all the main technologies they are using that. Docker and Kubernetes. Even you can use it normal web based application or RESTful API based applications or ML based applications. Very simplified with these microservice based application. We are going to talk at that. Yeah, we should know that as a DevOps engineer, how to manage that this Docker and Kubernetes based applications as well as. And the security is also which we should know that in the CI/CD process model. That is some security configurations. How do you apply it in the CI/CD process model? Yeah, if you just combine all these things as we are understanding. So here, if you just quickly go back to that here. So manual approach, this is a monolithic based application, monolithic. So this manual, you need to automate it. That is Terraform, Ansible, scripting, shell scripting. These are all mainly helping about it to provision the servers and to set up the platform and deploying finally application. This is one kind of an environment, a monolithic based application. But these days, microservice based application, that is Docker and Kubernetes environment. Is how to manage these Docker and Kubernetes based microservice services in the CI/CD process. So maybe you are going to get it CI/CD process about the monolithic application, or maybe you are going to get it in the CI/CD process about that container based applications. But that application may be either web application or MLOps based application, ML based application. See the beauty of that operation engineers now, the DevOps engineers. The role is increasing. The main objective is teams coordination. Yes, Kubernetes manages the Dockers. Yes. I'll come back. Don't worry. Just get the concepts of it. But if you dig into the more, I mean, that's required like one class itself to understand entire what is a Docker and Kubernetes. But it is a high level. So Terraform, Ansible, shell scripting, Docker, Kubernetes. These are all some important technologies we hear that's always in the DevOps process model. Okay, so now if you combine that, the power of, as we are talking about a DevOps engineer, developer and operations. Are we going to become, I mean, are we going to say the DevOps engineer is the developer? Can we confirm it? DevOps engineer, is he a developer? No. Okay. But that is wrong. DevOps engineer is also one of the developer. But which developer? Which kind of the implementation is doing that? We don't write application code. We go for that. Writing infrastructure as a code. Using the Terraform you are using is nothing but you are one of the developer. You are writing the code to manage the infra. So we are going to write Ansible scripts, shell scripts, Python scripts to manage the platforms. That is a configuration, like managing the 40 servers, 50 servers, or 100 servers. How do you manage it? Suppose we have that 100 servers. In all the 100 servers, I need to add one user. 100 servers, I need to add that one user. Oh my God. If it is a manual, I need that on each server at least 5 to 10 minutes. Like 100 into 5 minutes on an average. 500 minutes by 60. Those many hours of the time, if you give it, I will do that. But using this configuration management tool, once the script is ready to create a user on one system, the same script you can apply to that 500 servers, 1,000 servers, or 10,000 servers, doesn't matter that. That is the beauty of these configuration management tools. Within 1 hour, you can complete all the servers. Once that's the script is ready, within 1 hour, you can manage that 500 servers, applying that, creating user, or any change, that is deployment, or infra change, a platform change. That is the beauty of these configuration management tools. But who is going to write the scripts? That is Ansible scripts, Python scripts, or shell scripts. Yes, here Python we are talking that, but we are not the developer of that application. We are not implementing application related, but we are writing the code for infra management, platform management. See the beauty of the DevOps in it. And finally, deploying that application. Yeah, build automations. You need to convert the source code into binary file. We are talking that, right? But how do you convert the application code into binary files? We need to use it, some build tools. The build scripts. Yes, integrating. Yeah, cross platforms. That is hybrid models. Yeah, so we are going to work like as a developer, but we are not going to write that application related code, but we are going to write the code to manage the infra, to manage the platforms, or to manage the application delivery or the deployment processes. Yeah, these are all some important development activities, but these are all the scripts on the very easy. Don't get scared about it that. And operational activities. Yes, as a DevOps, operational activities. What are the operational activities we are going to do? Managing all these servers, monitoring about it. And if there's any kind of issues, yes, using that logs, checking about it, where it is got failed, and troubleshooting activities. Yeah, and then performance management, monitoring the server statuses, load on the servers, high load or peak load or non-peak loads. Identifying those points. There are some activities which we do that as a DevOps engineer. Yes, if anyone asks, that's what you are going to do that. I involved in the defining the CI/CD process. But to define the CI/CD process, what are the infra required, platforms required, or applications required? Yes, I write or we use it, the tools like a Terraform, Ansible, Shell, Python, or a Docker files, or Kubernetes scripts. They're all implementations on the basis of the microservice-based application or monolithic-based application. In that monolithic or microservice, if it is a web application or RESTful APIs applications or ML-based applications, it doesn't matter that which application. Yes, we go for that using all these. We are going to perform all these activities, but how you're going to perform that all these activities? We use the tools. So integrating all these activities and define together, we use the tools. What are the tools? Source code management. Yes, where do we store that source code? Can you give me the tool for it? Which tool do we use it for the source code to store it? Yeah, that is about Git and GitHub. Now, build tools. What are the build tools that we use it? Yeah, that is Maven. Now we are talking that. So we know the stages and process models, but to define it, we take the help of the tools. We don't do that like manually. So Git, GitHub, the Maven build tool, and code review, that is code quality verification. That is SonarQube. And how do we store that artifacts? That are the binary files. Where do we store it? That is, we use the Nexus for it. But how to manage this entire process? So any code is updated GitHub, pull the code and do the build, do the compilation and verify the code quality, then run the unit test cases, then create artifact, then artifact upload to the Nexus, then take that artifact and deploy to the servers. How do you do that? All these activities. Are you going to do manually? We use the CI server, that is Jenkins, or Azure DevOps, or AWS code build code pipeline. So different platform, different clouds or different environments, we have the different tools, but objective is the same. Yeah, we are going to work with the Git, GitHub, Maven, SonarQube, Nexus, Jenkins, and deployment platform that is about Linux, which we should know it. Configuration management tool, which we should know that Ansible. That is, if you have that 100 servers, 1,000 servers, 10,000 servers, within 1 hour or 2 hours, you can complete the activities. That is the beauty of these configuration management tools. How fastly we deliver that is important. And web or application servers, yes, which we should know, that is deployment servers, right? That is Tomcat, Apache, Nginx. We have that web servers, app servers. These servers, how do you manage it on the monolithic based application, or how do you manage that on the microservice based applications? And testing automation tools. Yes, we have the Selenium, JUnit on the base of the technology and like level of the test cases. And the scripting, yes, which we should have the shell scripting, Python. And you should have those monitoring tools idea. Don't worry about it, all this. But required all these things. Yes, as we're talking that container, that is Docker and Kubernetes, which you should have thus. This is the important technology, next generation technology. We are going to work with that Docker and Kubernetes applying to the web-based applications and as well as ML-based applications. As the course which you have taken that on the base of it. And cloud infrastructure. Yes, we should know the cloud as well as. That is AWS. And how to manage that, like all the issues, or how do we track that all the activities? So understanding about issue tracking tool and virtualization softwares, that is VirtualBox or the VMware. So all these tools together, that's which we should know it. So that is, we are going to discuss that anyway, all the points, all these tools, don't worry about it. The one by one, that is about our course content. Are you clear about that? The overall DevOps process model. I've got the clarity about it. The 5 principles of it. And as well as those 5 principles to manage it, what are the generic tools are available in the market? So these are all like, I mean, the main DevOps in it, if you talk it, yes, we are the developer, but we don't write the code for the application side. We write the code for the infra management, platform management, and application distribution and deployments. Those activities point of view, we write the code. But how do we? Yes, we use it all these tools. Here still I didn't mention that infra provisioning, that is Terraform. That is about one by one learning, don't worry. Sorry, clear about this, the agenda of the DevOps engineer? Type that CLR in the chat window if you understand. Yeah, good, good. CLR, CLR, CLR. So we'll come back all these tools the later, but tomorrow, which we are going to start about that. This is the cloud. The cloud infrastructure, that is Amazon. Yeah, you will get it. I'll share it. That. So already we are sharing about that DevOps related. So tomorrow we start about that, the cloud. So what is this cloud? What are the advantages? What is the difference between the data center and cloud? And why that Amazon? So this is the concept we are going to talk it this tomorrow. And then we start about that. How do we use the AWS to manage the infrastructure? If you need that virtual machines, how do you get it that? Or if you need the load balancers, or if you need that the scaling features, or if you need the storages, or if you need the databases. So how do we use it, this Amazon cloud? That is, we are going to talk with that, the first. Then one by one, we'll move into that. These are all the tools. But first, you should know the service management, right? Without having the service, then there is no meaning of that application deployment. Yeah, so tomorrow we start that Amazon, that is AWS cloud. So that is agenda. And that is about overall picture of the DevOps. Yes, whenever we talk with the DevOps, just to get the clarity about that integration, delivery, deployment, testing, and monitoring. But we are not going to do all the things manually. So we are going to use the different tools to manage it, all the principles of DevOps. But while managing all these principles, we are going to become as a developer, and as well as we are going to become this operation engineer. But development side coding that much not required. That is 20 to 30% of the scripting skills. If you have, that's more enough for the DevOps. That is required in the coming IT. So everyone is expecting to know the development. That is, we'll talk it one by one. Don't worry. Azure, if you need it, I have that like recorded video, some of the concepts, then we will share it at the end once the AWS has been done. Yeah, if you need that Azure. Yeah, fine, good. Thank you. That's all from my side for today. So we'll meet tomorrow and we'll continue on the Amazon. So any more queries, questions, please let me know in the chat window, or you can unmute it and you can speak it there. Okay, so silent, it represents that's about you, maybe you got the confusion or maybe you got the clarity on it, right? Okay, fine, good. So if you still, I mean, having some confusions on this, yes, just go ahead one more time. The recorded videos are uploading to the batch. Just go ahead and review once again and noted all the important points. Okay, so that's all from my side, and we'll meet tomorrow, and we'll continue starting with that AWS Cloud, one of the beautiful one. So very, very interesting, and don't miss the classes. Thank you. Thank you. Yeah, thank you.